everybody, today we are looking into our whole code of our Tic Tac Toe video, and we're going through every step the computer does to complete our game. And yeah, that's what we do today, and let's start right away. We want to go into all the code we have, so we also include everything above the main function. So we have to include all the libraries that we want to use, and then we have our globals, so we can enter a circle and the character will be also be equal to the letter itself. And then we have empty, tie, and no one, and those are just for our vector that it knows what he has to do. And then we have all the functions just to declare it that we have it in our program, that when we run it that they can be searched for. And then we are coming to the main function. The first thing the computer does is that we have a variable called move, that we have an actual number that we have to place somewhere in our vector, that we can place our x or our circle. And then we have a constant integer for the number of squares that equals to 9, because we have 9 squares in our board from our Tic Tac Toe. And then we say our vector character board is the maximum of num squares, that means the 9 squares, and it's empty. And then when we start we would have an empty board. And the next function we go to is just the introduction function. This is just for the player, that he knows how to play the game, that his numbers that he types in are from 0 to 8, that he can choose his field where he want to place his X or his circle. After that we want to decide who goes first, and then we ask the human character in our human piece function, do you want to start first, from the ask yes or no. We made this up here. We asked it with this question, yes or no, and we gave the response y or n, and then we could choose if we want to start or not. After that, if the answer was y, it returns our x, because we define that we want to start or with the x. So if the computer will start, it will start also with the x. So we have to adjust this, and if we are going second, we return the circle and we start with the circle. And then after that the computer will be defined, and we just make that the computer changes the value. If the human piece is x, it returns the circle, and otherwise if we are the circle, it returns the x. And after that we have defined that for both of them, we say the character turn, that is the definition down here, who is on the turn. We define that to x, so the x actually starts. And then we can display the board, and we defined the board before to empty, so we just display an empty board. And to visualize that, what the empty board looks like, it is display board here. It is the vector in itself, and it is declared with all the numbers that you can choose, and it just prints that out. And if you want to look at it, I can just start the program right away. And if we say we want to start first and we type y, you can see we will print out an empty field. And now I want to say something very important, because we declared our vector here with our 9 squares, and that every square in this vector is empty. And we defined this vector, and that what you just saw here is just the display. So it just displays what it is in our memory. This cannot be written over by something. That means if we change something, this doesn't change. It will only display the vector. And when at place number 0 is empty, it will display empty. And when we change something and the 1 or 0 is declared now by X, the memory is somewhere else, and it only displays us the places what they are at the moment. And that's the reason we had to declare our constant character globals, that it knows it is empty, so for the start that there is nothing inside. And when we declare a number to an X or a circle, it knows if it is a circle or a X. And that's very important to know, that the actual display is not here, it is in the memory behind it. And now we are coming to our main while loop. As long winner board is not equal to no one, it will repeat itself, and the human and the computer will play along, and each time it will be displayed what they made as a move, and it will turn to the other one. And first we go to the winner board to see when it is equal to no one. And here we have created an array with all the winning options that are here. And here you can see we included also total rows. We declared them separately because we need them to loop through. And then we made an if statement, and it should loop through all the rows. First we row through the first row, and we look in the first row if it's empty. And if it's not empty, then it continues and it looks if the first row and the second row is the same, and then it goes on and looks if the second and third row is the same. And if this is true, we can return a value, and we could return any value that we want, that we created here. For example, if this is all good, we could return the total row is 8. The program would still work completely fine, and we could also change that to row 1 or row 2 or to the line, but we set them to 0. And we can do that because we have later we can just do that, but we need that actually, the board winning rows 0, for the algorithm that we have later for the computer, that he knows where to place his X or circle to win. And if he has the winning rows, for example the first one, 0 and 1 is placed, then he knows he has to place on the last field, that means on the 2, and in this way he knows which row it is, and he can place his number on the right one. And for the algorithm is not important if here is a 0 or a 2. This was just to explain it for the algorithm, that this would not care at all. And for the general game, you could use what you want. If you would play human against human, you could return any value. And then we continue, and we have here an if statement for the tie. If it counts through, this is an algorithm command from the STL library. We begin at the board and go to the end and say if empty is equal to 0, so every place is full, it should return a tie. And when there is no option open, so nobody has won yet, and it is not a tie, it will return no one, and our loop up here will continue until somebody has a winner board. And now we go inside the human move to look how we can actually decide which place we want to choose. And for that, our move that we choose is equal to human move that will output our number that we place our X or circle, and it places into the board move the place that we have chosen from our vector, and this number will be in our memory stored, but in our vector that we have up here. And then we can move on to our human move. And here, as you can see, it's here. First, to have our integer move, we have to first ask for a number. And this will be made up here. We ask for a number. There's just a normal do-while loop. We have the question that we ask which number you want to place your X or circle on, and then you have from low to high. Low we have set equal to 0 up here in our function declaration, and the high number as well. And now we go and say you can choose a number from 0 to 8 because those are the fields that you can choose. Then you choose a number, and as long the number is high, not higher than high and not lower than low, it returns the number, and we go back to human move, and it will return our value, and then it checks if our move is actually legal, and this is here the our is legal function. It just checks is our field free, and if our board move, that is our command to check it, equals to empty, so the field is free, it can continue, and it will count out fine. But if we have already placed something in our field and it is not empty, it will write this place is already occupied, and then it asks again for the number, and it makes that until we have our actual number that we can place in our vector. And then it says board move, so the number that we have chosen is equal to human, so X or circle, and it will place it there in the form of an X or a circle. Before it was just the number in the variable move. And then we can go to the computer, the little AI that we have created for it. And for this we go down here, and that's the place where we figure out where is the best place to place our X or the circle. And for that we create a new move, and we equal that to 0, that we can loop through from 0, and we make a bool found that is equal false, and as long it is false we haven't found a number to go for, and it will be written in each section found, and the circumstance to make the found true, and if it changes to true then it will print us out our move and the best position to move our piece. And first we have to look for our winning move, because if we have the chance we want to have that first. And for this, as long we haven't found the right move, and the move is smaller than the board size, and the move is actually also legal, so the field is not empty. If this is the case, if it's empty, it can go for it, and otherwise it will add plus 1, and then it goes and checks for it. It places the piece on the right position to check it. And if this would be a winner move, it would equal the found to true. But if it's not, it empties this place again and it tries the next number. It puts the next piece and it places this piece on another place or the next one because it loops through. And if this one would be the winner board, it would be true. But as long it will always insert it and delete it, and in between it checks if it would be the winning board. And when we have checked this and there is no solution to it, we go to the next one, and here we check if the human could win in his next move. We check where we have to place our piece, and we change human to opponent computer because we want to check his piece. So we have to change our piece. If we are the circle, we have to change it to X and reversed. And for that we search if in the next move he could win. And if it would have found it, it would place his piece on the place where he could have won. And that's what this program does. It does almost the exact same, just that it has to change the circle to an X or reversed. And then we go to the last one. If there is no option that we had up here, we have the best next move, and we are setting the move again to 0 again as all the other examples, and make a new integer that is 0. And this is just to loop through it. And we have here the best move. We have 4, 0. This 4 is the middle one. This is the left upper corner. This is the right corner. This is the under on the bottom, the left corner, the right, and those are the ones in between. And to loop through them, we need to loop through them to look if the place is actually still available. And if the move is legal, we can say yes, we have found the number that we can place, and we place it there. And then it returns the value move to our main function up here, and then we have our value move, and this move is then equal to our move on the board, and it is equal to our circle or X from the computer, and it will add it to our vector. After that it displays our new board, what we have at the moment, and then it turns again to the human. And now we finally go to our last function that we use to say who has won our game that we played. And if the winner is the computer, it will say its text, and if the human is the winner, it will say his text, and else we just have one, it's the tie. Otherwise we don't have any other option. In this case, because it's like this, we can just write else, and it will know it is our tie. And with that, our program is done with everything. And the only last thing we can do is run the program. And the first thing you can see is, welcome to the Tic Tac Toe game, prepare to lose. Make your choice, choose a number between 0 and 8, and then we display where you have to place your number. And then let's begin. Do you want to start first? We have declared that by human piece, and we had to make the ask yes or no function, and we say yes please, and then good luck, you will need it, and then it first shows the display empty. And then which place do you want to choose? And we start with X, so we should be x when we place a number, and we place, yes, we place it at the middle, at the number 4, and then it continues. I shall take square number 0, the AI says, and then it places his circle and at the place of the 0. And we continue that, we go on with the 1, and then the AI notices it and placed his circle at number 7. We go on and place ours as number 5. The AI again notices that, and now we have to place it at number 6. And just for example, I choose a false place for just already occupied place, for example number 4 that we have chosen first, and then it says this place is already occupied, which place do you want to choose? Again, we could make a space here to make it a little bit nicer, but for now it's okay. We choose the new number, and the last number that we can choose is number 8, and then the program ends. You were the most lucky human and somehow managed to tie me. Celebrate, for this is the best you will ever achieve. And with that, the program ended and we finish. And that's it for the video today. I hope you learned something or enjoyed watching it. And with that, I say bye.